Okay, I'm going to do my best here to make how to graph tangent as simple as possible. So part of this has to do with the fact that we really have to memorize a few things to understand how to graph tangent. We need to memorize what y equals tangent x. In other words, the parent function, we need to memorize what that looks like. So we start with our x and our y axis. And if it's the parent function, if it's just y equals tangent x with no extra numbers, no vertical or horizontal shrink or stretch, no ups or downs or whatever, then what happens with our graph is we end up with asymptotes at pi over 2 and at negative pi over 2. Every single time that we don't have a horizontal stretch or shrink, that's where the asymptotes will be. And then our graph goes through 0, 0. It goes up to the right towards that asymptote. It goes down to the left towards that asymptote. In a similar manner to a cubic function, okay, to a positive cubic function. And then we could extend our graph left or right here, because really, this is one period that we drew, one period of tangent, and a lot of times they'll ask us to draw 2 periods. So to do that, we'd have to extend our graph one way or the other, and we would have to figure out, okay, well, where would this next asymptote be at? It's out here somewhere, but where is it? Well, here we're at 0, here we're at pi over 2, so if we go an equal distance, in other words, if we go pi over 2 more, then we'll be right here at pi. That should be our middle point. Then, and that's pi over 2 plus pi over 2, which is 2 pi over 2. So this should be 3 pi over 2. Okay, because these intervals here, where our tick marks are, those are pi over 2 apart. And so this middle point, it should go up to the right and down to the left. And now we've drawn 2 periods. So here's the information that you need to memorize. Tangent goes through 0, 0. Okay. If it's not moved left or right or up or down, it should go through 0, 0. Its 2 asymptotes are at negative pi over 2 and pi over 2, unless it's got a horizontal stretch or shrink. It goes up to the right, and it goes down to the left, like as far as, not really in behavior because we've got asymptotes, but as far as that goes. And the period of it is pi, because every pi we repeat something. So one thing we're doing whenever we're graphing the book is it's asking us what the vertical asymptotes are. And so when we write vertical asymptotes, what we want is we want to pick one vertical asymptote. So here we could pick pi over 2, or we could pick negative pi over 2, or we could pick 3 pi over 2. Any asymptote, it doesn't matter. And then we say plus, and we say how far apart our asymptotes are, which if you look, our asymptotes are pi apart, because that's the period of our tangent function. So we could say pi over 2 plus pi k, where k is an integer. Okay, and remember we talked about in the 4.5 video, we talked about a fancy way of writing k as an integer is to write k with a fancy e and a fancy z. So whichever way you want to write that is fine. But there's our basic graph of tangent x. So let's figure out how to apply that now to something that's been changed a little bit. And we're not going to go too hardcore. We're just going to make it a little bit different, really. So let's graph y equals tangent 2x. And let's think about what this is going to do to our graph. This 2, just like with sine and cosine, we take the reciprocal. So this is horizontally shrunk. So I'm going to say it's a horizontal shrink of 1/2. Well, that means that we're taking all of our x values and we're shoving them closer to 0, 0 as far as their x's go. Not their y's, just their x's. So normally our graph goes through 0, 0. Well, that's not going to change. If I move 0, 0 in halfway closer left and right. It's still at 0, 0. But what will change is that normally we are at negative pi over 2 and positive pi over 2, but we're shrinking by a half. So what we do is we take that value and we times it by a half to figure out where our asymptotes should be. They should be this time at pi over 4 and at negative pi over 4. Because we just moved them in halfway closer horizontally to basically to the y-axis. So this should still have its general shape. Then we need to think about where our next graph would be. If we extend this out this direction so we can draw another period of the graph, well, first off, what is the period of this graph? We normally have a period of pi, and so we divide that by 2, and our period for this is pi over 2. So our next asymptote is going to be pi over 4 plus pi over 2. Or we can think about that this interval is pi over 4 long, and so we can make tick marks that are at a length of pi over 4. That would make this be 2 pi over 4, which is pi over 2, and that would make this be 3 pi over 4. So that gives us that vertical asymptote up to the right, down to the left. So negative in front, just like always, will flip our graph, so it'll go up to the left and down to the right instead of what we originally have. We can shift these left to right, up and down. The vertical stretch is hard to represent graphically, but we can do that as well. The vertical asymptotes on this one, again, we pick an asymptote, so I can pick pi over 4, plus how far apart are our asymptotes? Well, the period of this is pi over 2, and that's how far apart our asymptotes are. So I like writing it this way because it's fancy and it takes a little less room. So pi over 4 plus pi over 2k, where k is an element of the integers.